Yay, another rational function. We are going to talk about VAs, we're going to try to talk about HAs, XInts, YInts. It's all about where to look, and then getting some guidelines in the grid and going from there. If I see things I can factor, I will want that other form. There's a common factor here of 2x, so I'll factor that out. This will come in handy when I'm trying to find x-intercepts. The denominator, there's nothing I can do. Nothing I can do. Leave it just like that. So vertical asymptotes are going to be any place that might cause division by 0. Because we're not allowed to cross vertical asymptotes, and we cannot ever divide by 0. So I'll look at this denominator and know that the VA is that x equals -1. I'm going to write that as an equation of a line. So I'm going to say x equals -1. I'm not just going to write -1. It needs to be a line. I'll draw the guideline for me, splitting the grid into 2 regions, one here and one here. Each of these will have to have graph in them at some point. As far as the HA is concerned, we're talking about what happens when x gets very far away from 0. And when x gets very far away from 0, it's the lead terms of each function that take over. So I just want to focus my attention on this 2x squared over this x. Now this can be reduced to straight up 2x, and I'm thinking about x's that are far from 0. So if x is really big, 2x is just getting bigger and bigger and bigger. And if x is really negative, 2x is more and more negative. It's growing without bound. So this means there's not going to be any kind of horizontal asymptote. However, this is like a linear function. So we can say more about what this is going to do. And this is the whole oblique or slanted asymptote idea. So when this top is exactly one more, when the degree of the numerator is exactly one more than the degree of the denominator, there'll be a slanted asymptote that we can find. And here's how we find it. We take this expression, and we're going to bust out good old synthetic division. I'm going to take a 2x squared minus 4x 0 and divide it by x plus 1. So I'll throw a -1 out here. We'll do our good old synthetic division steps. That leaves us with this function, 2x minus 6. And there's a remainder. And if you have a remainder, you can write it as remainder over divisor if you wanted to. But keep in mind that we're talking about x being really large, and 6 over really large goes to 0. So this part, we can ignore this, and we can ignore this, and whatever linear function this creates, that is going to be the line we graph for our asymptote. Which means I'm going down 6 and making a dot, and going up 2 over 1, up 2 over 1, up 2 over 1. Okay, so this is, and I'm going to draw a dotted line that follows those points. It's a little awkward. I do want you to try to picture this as, hold up, yikes. Okay, I want you to picture this as a line that was like this, and then got like slanted all of a sudden. There's still 2 sections. It's going to be really hard to pick out what's going on over here. I wish this book played out differently. But that's an asymptote. There's still 2 regions. X-intercepts are going to be whatever makes that numerator 0. So that numerator is 0 when x is 0 and when x is 2. So I'm going to have a point here, and I'm going to have a point here. The y-intercept is what I get if I plug in 0 for x. If I plug in 0 for x, the top is 0. Well, I already have the y, it's right there. Okay. So let's talk about this. In this region of the graph, I need to figure out if the graph I'm going to draw is above this green line or below this green line. I've got a couple points right here to help me figure that out. Since I've got points here and here, I've got to connect them. They have to approach this green line, and they have to approach this red line. So it seems to me like if I think about connecting these points and I want to approach that slanted line, it'd be like this. And as I get closer and closer to that line, I'm going to go up like this. Boom. So I do have one piece of graph in this region. On this side, I have to approach this line, so I'm going to have to start down here. I don't know if I'm on which side of the asymptote I'm on, but I do know that if I start to approach the vertical line, I can't veer up without going to the x-axis. That's not going to work. So on this side of the red line, I'm doing something like that. And that's how it's going to look. We'll try one more of these in another video, but it's really the same steps we just found for the horizontal asymptote, but it's you're trying to think of it the same way as best you can, and we'll talk about it more in class on Monday if that's required.